My name is Ray Wolfe, and I really appreciate the opportunity. Unfortunately, we're doing this in a virtual environment. I was hoping that we could do this face to face, but at some point we'll be back to what it was at one point in the past. I'm going to talk a little bit about what we're doing, the innovation that we're bringing forward in the passenger rail space, focused on hydrogen. And so what you see on the screen is the passenger vehicle, and I'll talk about that. But before I jump to that, I want to kind of provide some context. Our organization is responsible for improving mobility throughout San Bernardino County. And yes, we are east of LA. We're not East LA, right? But we are the largest county in the United States by landmass. And so we have a lot of challenges trying to address the movement of people and goods through our county. We're sort of the epicenter of the goods movement for much of the American economy. We saw in Pace's presentation the focus on the large shipping vessels that bring goods to the ports, largely here in California, the ports of LA and Long Beach being the largest port complex in the United States. And those goods actually traverse through our communities as they head to markets outside of California. So one of the things that we have focused energy on is improving transit alternatives for our population. And as we did that, we are nearly completing the construction of a 9-mile extension of our commuter rail system here in Southern California. We call it Metrolink. It's a system that operates on 538 miles of Class 1 track, a railroad track, throughout 6 counties here in Southern California. And this 9-mile extension is in the east part of the San Bernardino Valley. And what we wanted to do, our vision for this project, was more than just providing commuter service to these communities. It was to try to really excite the communities to look at passenger rail as an alternative to driving around. And so even though we're just looking at a 9-mile stretch and it's an extension of the Metrolink system, we didn't want to just bring the locomotive hauled coach consist that represents the Metrolink commuter rail system to bear in these communities. We wanted to bring in something that was more modern, lighter, more fuel efficient, to really try to bring excitement around the idea that rail transit can provide. The corridor that we're building is a joint use corridor, and so we weren't able to introduce light rail because that would have been the obvious solution initially. And so we finally landed on what's called a diesel multiple unit, and that's the vehicle that you see on the screen. Now, what I'm showing you is a 2-passenger vehicle consist. These are expandable, so you can add multiple passenger cars to this consist, depending upon the demand and the system that you're operating. But what's really interesting about this vehicle type, and I talked a little bit about sort of where we are relative to the ports of LA and Long Beach. The particular 9-mile extension, as I said, was in the east part of the San Bernardino Valley, which just so happens to be surrounded by mountains. And why that's important is we have an onshore flow for much of the year here in Southern California that pushes a lot of the pollutants from the ports of LA and Long Beach into the eastern San Bernardino Valley, Metro Valley area. And so we have a lot of air quality concerns that as we're developing transportation infrastructure, we have to be mindful that we don't want to further exasperate the air quality problems for the communities that would be affected. And so what's interesting about this vehicle is it is configured just like a light rail or a subway vehicle. That is, it uses electric traction motors on the wheel sets that draw power from generators that you see in the power cab or power pack that's highlighted in green in the middle of the consist. So it doesn't draw from an external power source like a light rail or a subway system, but rather it generates self-contained power. And so as we were struggling with, trying to bring in something innovative, and trying to address the air quality concerns, it seemed rather obvious to us that all we have to do is pull the power pack out, swap it with a zero emission power source. The train's already configured to do that. It's basically plug and play. But that's obviously a really simple viewpoint, right? It takes quite a bit more. We heard from Pace that, even though we're looking at taking off the shelf proven technologies and sort of plugging them in to the system, it's all about application engineering, right? So you've got to figure out how all of the pieces come together and actually work together. And so that's what we're doing right now. And we partnered with the State of California Transportation Authority. We partnered with the State of California Caltrans and with the California Air Resources Board to secure a grant to prototype this vehicle. Now, I talked about the 9-mile project that we're constructing, the extension of Metrolink. And so our initial thought was battery electric would work great. And in fact, the analysis that we did, that worked fine for that 9-mile stretch. But we wanted to do something more monumental. We didn't want to just introduce this technology and just have it work in a 9-mile railroad at the eastern end of the San Bernardino Valley. But what we wanted to do was introduce this technology so that it could be useful throughout the 538-mile Metrolink system or on any other commuter rail system in North America that operates on Class 1 railroad tracks. And the battery electric technology simply that it doesn't work as efficiently, because what happens is if you're going 60, 100 miles, you don't have enough in the battery pack because you've got this point where batteries begin to outweigh the benefit that you're receiving. And so you either have to increase the dwell times at intermediate stops along the way to boost the charge in the battery pack, or put up partial overhead catenary, something where you can recharge the batteries. And that just isn't efficient for what we're trying to accomplish when we're trying to attract people out of their cars if you're waiting for extended periods of time to boost the energy in the battery pack to make it from one end to the other. And so then we started to look at fuel cells. And very quickly, we realized that that was the opportunity to really replicate the range of a diesel-powered system. So ultimately, we landed on a hybrid solution, and that is we still have batteries on board because there's a significant elevation change throughout the Metrolink system, and we didn't want to lose the regenerative braking power to heat, right? We wanted to recapture that energy and use that to help propel the vehicle and run the air conditioning systems, et cetera. So batteries are still part of the solution, but the primary power source are fuel cells. We're expecting that for a 60, 65-mile run from LA Union Station out to the University of Redlands, that we'll need about 300 kilograms of hydrogen. And so we're in the process right now of finalizing the design. It'll be done before the end of the calendar year. And they've started manufacturing the vehicle now in Switzerland. We're partnered with a Swiss rail manufacturer called Stadler. And what's really exciting to me is while we don't have this ready to go today, it'll be here for testing in San Bernardino within a few short years, within 2 years. The manufacturing should be done by the end of next year, and then there'll be some testing that's done in Europe before it's shipped over here for final testing. So a lot of really exciting things. The other piece of this that we're analyzing is how where we're going to secure the fuel, right? So there are hydrogen itself is odorless, colorless, and clean, but it's how you generate the hydrogen that really becomes important. And that's a question that I had posed to the moderator. I'd be interested to hear both from Pace and from Philippe when the presentations are done, how you're looking at generating that. We're hoping to partner with private industry because we have a lot of warehouses, large warehouses in the area that are starting to convert a lot of their essential vehicles to fuel cell. And so looking at a potential public-private partnership, but hoping to get to a 100% green hydrogen, which is a daunting task in today's environment.